Hi, this is Rutul Desai. Today I'm going to represent our graduate research project on the scalesum extension to support the GNN inputs and CNN backpropagation. Nowadays, we have seen that the training time for the machine learning model increases for the large-scale inputs, and there are the several AIs and the models which has taken a few weeks or the months to get trained, which ultimately increases their training complexity. So the scalesim is an open-source CNN simulator, which is based on the systolic array and uses the three SRAMs, and this architecture is quite similar to Google TPU. So that's what the covered in the introduction. As part of the innovation, we extend the scalesim to support the CNN backpropagation, and we also integrate the scalesim with the booksim to support the parallel CNN training, and extend the scalesim to support GNN training via GraphSage to generate the node embeddings. Now, she will talk about the methodologies.
Hi, I'm Akshaya. As part of CNN training, we plan to extend ScaleSim, an open source simulator of a CNN training, to support backpropagation. In order to support backpropagation, we must compute gradients of the loss function with respect to the weights and biases. Later, update the weights and biases using gradient descent. Later, we move on to the training the model for a specific number of epochs by computing forward and backward pass for each epoch. And later, we will be updating the weights and biases respectively. Then later, we move on to the predictions, which we will be occurred by during the training of computing the forward and backward pass. We round the output nearest to the integer, which is 0 to 1.
Okay, if we talk about the GNN input extension, then the systolic array-based GNN simulator is taking the input as a graph in the non-Euclidean space with the nodes and edges and the set of associated features. So the graph input looks like the adjacency matrix and the feature matrix, where the adjacency matrix is a square matrix that describes the connection between the nodes in the graph, and the feature matrix is the matrix that describes the features associated with each nodes in the graph. Once the graph input is pre-processed in the form of the matrix representation, then it is fed into the graph embedding technique that we call it as a graph sage. And GraphSage is a graph embedding technique that learns the embedding of the node in a graph by sampling and aggregating the information from the neighborhood of each node. After that, we are using this pooling technique to pool those embeddings in a certain range to ease the computation process in upcoming steps. So as an input to the scalesim, the weights of the CNN needs to be specified and trained in addition to the pooled graph node GraphSage embeddings. Now, she will talk about the results.
As part of our results, as you can see, we successfully executed the ScaleSim simulator in a KSU HPC environment. So while part of execution, we used several different kinds of systolic array sizes. So the below picture describes the system for the various summarization between the values regarding input configuration, run and stall cycles, and efficiency and computation utilization and offset access bandwidth values like that for systolic array size of 32 by 32. And later we also used to provide a comparative graph for between the various systolic array sizes we used during the execution. So in that we noticed that as part of as the systolic size increases, the cycles count gets decreases respectively.
Okay. To summarize, we explored the core structure of the scalesim to extend the support of the parallel CNN or GNN training. And from CNN point of view, we have done the research on how to extend the backpropagation in the scalesim and integrate with the open source network simulator like booksim. And from GNN point of view, we explored the GraphSage embedding methodology to ensure that the GNN inputs could fit into the parallel training simulator. And our purpose is to build an open source simulation tool to evaluate the CNN or GNN training systems via integrating scalesim and booksim. These are some references that we have used. Thank you.